Hey science fans! Today I'm going to talk a bit about some physics waves. So we're going to do about the electromagnetic spectrum, which is a group of waves that we put in order in frequency and wavelength, and you need to know their uses, dangers and properties, features of these waves, these wonderful, wonderful waves. Come on, like, funny my eyes look all reflected, could have turned some stuff off. Let's get going and do some physics, shall we? This one's good for revision. Let's go. EM, or the electromagnetic spectrum. So they have some things in common, but what we're first going to talk about is how that they are a spectrum of waves. So in the same way that red, orange, yellow, green, blue, indigo and violet are the spectrum of colours, these are the spectrum of different waves, moving from a long wavelength with a low frequency measured in hertz to a short wavelength and a high frequency. Okay, and these are a spectrum, so there's lots of different ones with different frequencies and lengths. We put them in order depending upon their frequency and their wavelength. So the longest one is radio waves. Okay, and the ones with the shortest wavelength and the highest frequency are gamma waves, made of high frequency waves. This might be why I have no friends. And then we've got X-rays, ultraviolet rays. In the middle we have light, and in that we have red, orange, yellow, green, blue, indigo and violet. Then we have infrared, and then we have microwaves. And we need to know uses, dangers and features of all of these waves. Doesn't get more exciting than this. Boom. So we need to know key properties of all of the waves. So the main differences between them are their wavelengths and their frequencies, okay? So the longer the wavelength, they're more to the radio end of the spectrum, and they will then have a lower frequency. So frequency is the number of waves per second measured in hertz. Wavelength is measured in meters, okay? Things that they all have in common are they all travel exactly the same speed through a vacuum. So all of them, without any material to travel through, so a vacuum has no material to travel through, all of them will travel at 300 million meters per second. That's the speed of light, because light is an EM wave. So they all travel at the same speed in a vacuum. Different materials will mean that they move at different speeds. Fact. All of the different types of waves come from a source, and they are taken in by an absorber. So the source, for example, of light rays and infrared waves could be the sun, and infrared waves are absorbed by particles in our atmosphere, and light as well is absorbed by all different objects. And the last thing is that the type of wave they're all transverse waves. And the thing that we need to know about transverse waves is that the oscillation of the wave goes up and down, so it's perpendicular to the movement of energy flow. So if the energy is moving that way, the light ray is moving that way, there will be a perpendicular movement in the wave, up and down, 90 degrees. They're the properties of EM waves. Let's get on with the uses and the dangers. The uses and the dangers. So I'm going to put the uses here and the dangers here. Okay, so the higher the frequency, generally the more dangerous we consider them. We consider gamma rays more dangerous than microwaves and radio waves. So the main uses that you need to know for gamma waves is that they are used to sterilize things, because they kill bacteria. So they might use to like irradiate strawberries, for example. They kill bacteria, but they sterilize equipment used for surgery. They are also used as a cancer treatment, radiotherapy. Now the dangers of them is that they can kill cells. So when we do radiotherapy to kill cancer cells, they can kill healthy cells as well. So we have to use a very, very precise, small amount of gamma radiation to do those. Okay, and they can also cause mutations in cells, which can lead to cancer. Okay, but sterilizing equipment and cancer treatment, very useful. X-rays obviously are used to do bone imaging, because they pass through certain tissue and they'll be absorbed through certain tissue and they'll reflect through certain tissue, so we can get a really accurate image. They're also used for security. If you've ever been to an airport, you'll see that. Dangers, again, they can cause cell mutations, which can then lead to cancer. If you saw the picture of the guy that first invented the X-ray, he showed so many people his X-ray that in the end he had a very tumorous hand. Ultraviolet waves are They're close to violet in colour, they can't be seen. One of the brilliant uses of UV is bees use them to identify different types of flower and to follow pathways because they can see in UV light. They're used for security as well, so for marking objects, and they're also used for tanning beds, which is a terrible idea. Don't do that, because they can cause skin melanomas or skin cancers. They can cause the cells to mutate and continue growing. Very common cause of cancer. Look after your skin. Regular white light uses are for vision, cameras and photography, and some dangers is that we can cause cataracts, and also can have sight problems if you can't spell all of them, sight issues if you shine bright lights into your eyes. You know that you can damage your retina. Okay, let's move down to infrared. So infrared is used for communication. Your phone will use it for communication, remote controls will use it for communication, and also for heating. If we want to heat things up, we tend to use infrared radiation. Those little bars on your grill or in your kettle or in your toaster, that's infrared radiation. Danger: burns. Microwaves can be used for heating food, but can also be used for communication. So mobile telephones use microwaves because microwaves can penetrate the atmosphere. So we use them for global satellite communication. So they can be used for food. Microwaves can be used for food because they vibrate the water molecules in food. They can be used for communication, mobile communication, because they can penetrate the atmosphere. So if I want to call someone in Australia, my microwaves are going to go to a global satellite. Then they're going to be bounced or reflected back into onto Earth. Dangers of this: they can heat up the molecules, so they can kill cells because they can heat up the molecules too much by the vibration. So do not put animals in a microwave to warm them up. It's bad. Radio waves, again, used for communication. There are short waves and long waves, and that will depend on the type of TV or radio signal that you'll get. There are no known dangers of radio waves. We've been using them for quite a while. We don't know what the dangers are of microwave communication are, really. We haven't really been using mobile phones long enough, but no known ones for radio waves, so keep an ear out. What a miserable day outside. Look how horrible it is outside. It's gross. Okay, so that is it. That is the electromagnetic spectrum, essentially. That's all you really need to know. Like all waves, they can be transmitted through a material, they can be absorbed by a material, they can be reflected, they can be refracted, all of those things, because they're all waves. Sometimes it's a very simple material that can stop them, like paper can, or a book can absorb light rays and stop them, whereas you need lead or concrete to stop gamma waves. But you just need to remember they're all waves on a spectrum with varying lengths of wavelengths, frequencies, uses, dangers, etc. Have a great weekend. Bye.